morning to all. Welcome to Sigma e-learning Smart Way to Excellence. The topic we'll discuss today is the triangles. What is triangle? Triangle is any two-dimensional figure which has three sides and three angles. For example, take this yellow triangle. It has three sides. This is the side 1, this is the side 2, this is the side 3. Also, it has three angles. Angle 1, angle 2, angle 3. So, any two-dimensional figure with three angles and three sides, we call it as a triangle. For example, consider this. It has four sides and four angles. So, cannot say this as a triangle. What is the triangle? Now tell me what is the triangle. Triangle is any two-dimensional figure with three sides and three angles. Then only it is a triangle. Congruent versus similar figures. What is the difference between the congruent figure and the similar figure? Similar figure is any two figures having the same shape. Then we call it as a similar figures. For example, this is the small rectangle. This is the large rectangle. Both are in the same shape. So we can call it as a similar figures. What is the congruency of any two figures? Simple. The congruency is two figures or objects are congruent if they have same shape and size. For example, see here, this blue triangle, this yellow triangle looks are similar. They are looking very similar. At the same time, their sides, their angles also the same. Which means that when we place a yellow triangle upon the blue triangle, it exactly matches. So then only we can conclude that two figures are in the congruent nature. For example, consider this yellow hexagon and blue hexagon. When we place a blue hexagon on the yellow hexagon or yellow hexagon on the blue hexagon, they are aligned perfectly each other. So this type of figures are congruent figures. Consider all the congruent figures are similar in the nature, but not all the similar figures are in the congruent nature. For example, means consider these all are the congruent figures. Also, these all are similar figures also. These all squares are similar, but they are not congruent each other. Why? Because if we place a small rectangle on the large rectangle, they are not perfectly aligned each other. So they are not the congruent figures. So we can conclude here that all the congruent figures are similar in the nature, but all the similar figures are not congruent. So they are not the congruent figures. The point 2. Two polygons of same number of sides are similar if and only if their corresponding angles are equal and their corresponding sides are same proportion. Means that, for example, consider this is the one polygon, this is the another polygon. Both are looking the same. Also, we have to check these 2 points. Corresponding angles are equal. Means corresponding angles means this is the corresponding angle of this. This is the corresponding angle of this. This is the corresponding angle of this. The same manner, the corresponding sides. For example, this is the corresponding side of this. 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 We have to check these two cases. Their corresponding angles are equal. We know by observing this figure, we can say that their corresponding angles are equal. Why? Because in this corner it's a 70 degrees. Also in this corner this is also 70 degrees. In this corner it's 85 degrees. Here also 85 degrees. In this corner it's 105 degrees. This is also 105 degrees. Here in this corner 100 degrees. Here in this corner also 100 degrees. So here the corresponding angles are equal in the nature. And also we'll check another thing. The corresponding sides are in the same ratio. Means corresponding ratios are same size in the means the ratio of this side by this side, also the ratio of this side and this side, the ratio of this side and this side, the ratio of this side always equal. For example, consider this case. What is the ratio of this and this corresponding sides? 2.4 by 4.8 equal to 2.1 by 4.2, equal to 2.5 by 5 equal to 1.5 by 3. Means all these ratios are equating to the 1 by 2. If you want, you can cross check in the pen, cross check with the pen and paper. So if any two polygons are similar in the nature, we have to follow the two conditions. The first condition is corresponding angles are equal in the nature, and also the corresponding sides are in the same proportion. Okay, these are the two conditions to be followed by the any polygon to call it as a similar figure. Then coming to the second example, see this. Please check the similarity of these two polygons. What is the first condition? Corresponding angles must be the same. See, here also 90 degrees, 90 degrees, 90 degrees, 90 degrees. Here also 90 degrees, 90 degrees, 90 degrees. So the first condition has been satisfied. this condition has been, the corresponding angles are equal. So this condition, first condition has been satisfied for these two figures. Also, now we can check the second condition. What is the second condition? Their corresponding sides are in the same proportion. In the above figure, what is the proportion of their corresponding sides? Just 1 by 2. Now check. Now we will check the corresponding. Now in this figure, we will check the corresponding sides proportionality. For example, 3 by 3.5, 3 by 3, 3 by 3, 3 by 3.5. Why? Because these all are corresponding angles. 3 by 3.5 equal to 3 by 3 equal to 3 by 3 equal to 3 by 3.5. Means their proportions are not meeting as per our conditions, which is explained in the point number 2. So we can say that these two figures are not the similar figures. Why? Because at the condition 1, which says that the corresponding angles are the same, the condition 1 is satisfied, but the second condition says that the corresponding sides must be proportional to each other. This condition is not satisfied in this case. So we can say these two figures are not in the similar nature. Already we have discussed the similarity of any two polygons. Now we will discuss the similarity of the any two triangles. Basic proportionality theorem saying that if any two triangles are similar, these two similar triangles must be satisfy the following two conditions. Simple. The first condition is the corresponding angles are equal in the nature. The second condition is corresponding sides are in the same ratio. Also, these two conditions already explained in the for the conditions to be followed by the any polygon. Corresponding angles are equal and also corresponding sides are in the same proportion. The same rules also applicable for the any two triangles to be called as a similar triangles. Okay. Basic proportionality condition saying that these corresponding sides are must be proportional in the nature, means the ratio of AB by DE must be equal to the ratio of BC by AE. Also, it must be equal to CA by FD. So this is the second condition. So these are the two conditions must be checked to call any two polygons or to call any two triangles as a similar figures. See theorem number 6.1. The theorem number 6.1 says that if a line drawn parallel to one side of the triangle to intersect other two sides of distinct points, the other two sides divide the same ratio. The other two sides divided in the same ratio. Theorem 6.1 says that if a line drawn parallel to one side of the triangle to intersect other two sides of the two sides in distinct points, the other two sides are divided in the same ratio. What it means to say that, for example, ABC, this is the one triangle, a line which is parallel to third side. For example, in this figure, DE is the line parallel to BC, which is cutting the AB and AC line at distinct points. For example, this parallel line is parallel to BC, cutting the point AB at D, cutting the point AC at E. In this kind of situation, the ratio of AD by DB equal to AE by EC. Also, the ratio of AD by AB equal to AE by AC. So, this is also come under the basic proportionality theorem. But in the figure 6.17, 1 and 2, DE is parallel to BC. Find the EC in the figure number 1 and also AD in the figure number 2. Simple. We have to apply here the basic proportionality theorem. Also, theorem 6.1. Theorem 6.1 simply says that in a triangle, any line which is parallel to one side of the triangle cut the other two sides of the triangle at different points. In this figure, DE line which is parallel to BC cutting the line AB and line AC at point D and point E. In this situation, according to basic proportionality theorem and theorem 6.1, we can say that the AD by DB equal to AE by BC according to theorem number 6.1. So I drawing here AD by DE equal to AE by EC. So what is the length of AD here? 1.5 meters. Sorry, 1.5 centimeters. What is the length of DB? 3 centimeters. What is the length of AE? 1 centimeter. What is the length of EC? We have to find out. By solving this, we can conclude the length of EC equal to 2 meters. Okay. Theorem 6.1 simply says that in a triangle, any line which is parallel to one side of the triangle cut the other two sides of the triangle at different points. Figure. Here also we have to apply the basic proportionality theorem and also theorem number 6.1. Here also we have to find the AD value simply. So again, I'm explaining any one line which is parallel to one side of the triangle, cutting the other two lines of the triangle at distinct points, that points are D and E. At this kind of situation, the proportion of AD by DB equal to AE by EC. So AD by BD equal to AE by EC. We know that AD equal to, we have to find out. So I am keeping the AD in the say as it is, by BD equal to, we know that 7.2. So I am substituting 7.2 equal to A. What is the AE? This is 1.8 centimeter, by what is EC? This is 5.4 centimeter. By solving this, we will get the AD equal to 2.4 centimeter. For any doubts from this chapter, please comment me in the comment section. Also, raise your personal doubts. I will definitely reply on. Thanks for listening. Keep watching Sigma E Learning Smart Way to Excellence. Bye bye.